Myself S. Nithya, Assistant Professor, Department of Computer Technology. Let me start by explaining what database is and DBMS, Theoretical Relational Languages, Data Modeling and Normal Forms. First one, database. A database is an electronic store of data. It is a repository that stores information about different things and also contains relationship among those different things. A person, place, event or item is called an entity. The fact describing an entity are known as data. For example, if you were registered in a college, you would like to have all the information about the students. Each entity can be described by its characteristics, which are known as attributes. For example, some of the likely attributes for a college student are student identification number, last name, first name, phone number, gender, and date of birth. Next one, relationship. The relationships are classified into three categories: one to one relationship, one to many relationship, many to many relationship. One to one relationship. A one to one relationship is written as 1 is to 1 in short form. It exists between two entity set X and Y. If an entity in entity set X has only one matching entity in entity set Y, and vice versa. For example, a department in a college has one chairperson and a chairperson chairs one department in a college. Next one to many relationship. A one to many relationship is written as 1 is to m. It exists between two entity sets X and Y. If an entity in entity set X has many matching entities in entity set Y, but an entity in entity set Y has only one matching entity in entity set X. In such a situation, a 1 is to m relationship exists between entity set X and Y. For example, a faculty teaches for a one division in a college, but a division has many faculty members. The relationship between division and faculty is 1 is to m. Next, many to many relationship. A many to many relationship is written as m is to n or m is to m. It exists between two entity set X and Y. If an entity in entity set X has many matching entities in entity set Y, and an entity in entity set Y has many matching entities in entity set X. For example, a student takes many courses and many students takes a course. Next, database management system. The database system consists of the following components: DBMS software package such as Microsoft Access, SQL Server or Oracle. Custom applications such as data entry forms, reports, queries and programs. Computer hardware, personal computers and mini computers. Software, an operating system and a network operating system. Data are the raw materials. Information is processed, manipulated, collected or organized data. The information is produced when a user uses the applications to transform data managed by the DBMS. Next, relational database management system. A DBMS based on the relational model is also known as a DBMS or DBMS. It manages all day-to-day transactions. It performs bookkeeping duties. So the user has data independence at the application level. The applications do not have information about data characteristics. It allows users to specify validation rules. It secures access through passwords, encryption, and restricted user rights. It allows user to share data with data logging capabilities. Next, integrity rules. There are two integrity rules: entity integrity and referential integrity. Entity integrity. No column in a primary key may be null. The primary key provides the means of uniquely identifying a row or an entity. A null value means a value that is not known, not entered, not defined. A zero or a space is not considered to be a null value. The primary key value is a null value in a row. We do not have enough information about the row to uniquely identify it. Next, referential integrity. A foreign key value may be a null value, or it must exist as a value of a primary key in a referenced table. Next, theoretical relational languages. EF code suggested two theoretical relational languages to use with the relational model. First one, relational algebra, it is a procedural language. Next one, relational calculus, it is a non-procedural language. Relational languages can work on the entire table or on a group of rows. The relational languages provides more power with a very little coding. Relational algebra. The 9 operations used by the relational algebra are union, intersection, difference, projection, selection, product, assignment, join, division. First one, union. The union of two tables result in a retrieval of all rows that are in one or both tables. The duplicate rows are eliminated from the resulting table. The resulting table does not contain two rows with identical data values. There is a basic requirement to perform a union operations on two tables are both table must have the same degree. The domains of the corresponding column in two tables must be same. Such a tables are said to be union compatible. In mathematical set theory, a union can be performed on any two set. But in a relational algebra, a union can be performed only on a union compatible tables. Next one, intersection. The intersection of two tables produces a table with rows that are in both tables. The two tables must be union compatible to perform an intersection on them. Next one, difference. The difference of two tables produces a table with rows that are present in the first table but not in the second table. The difference can be performed on union compatible tables only. Projection. The projection operations allows us to create a table based on desirable columns from all existing columns in a table. The undesired columns are ignored. The projection operation returns the vertical slices of a table. The projections is indicated by including the table name and a list of desired columns. Next one, selection. Selection operations select rows from a table based on a conditions or a conditions. The condition operators and the logical operators are used along with the columns and values to create conditions. The selection operations returns horizontal slices from a table. Next one, product. A product of two tables is a combination of everything in both tables. It is also known as a Cartesian product. The first table has x rows and the second table has y rows. The resulting product has x into y rows. The first table has m columns, second table has n columns. The resulting product has m plus n columns. Next one, assignment. This operation creates a new table from existing tables. We have been doing it throughout all the other operations. Assignment gives us an ability to name new tables that are based on other tables. Next one, join. Join is one of the most important operations because of its ability to get related data from a number of tables. Join is based on common set of values which does not have to have the same name in both tables but does have to have the same domain in both tables. When a join is based on equality of values, it is known as a natural join. Next one, division. A division operation is the most difficult operation to comprehend. It is not as simple as division in mathematics. In relational algebra, it identifies rows in one table that have a certain relationship to all rows in another table. The 9 operations provide user with a sufficient set of operations to work with the relational databases. Some of the operations are combination of other operations. Next one, relational calculus. Calculus is a non-procedural language. The programmer specifies the data requirement and the system generates the operations needed to produce a table with required data. The general syntax is result equal to column list colon expression. The list of columns is on the left of the column and the expressions are on the right side. Next one, data modeling. A model is a simplified version of real life complex object. Databases are complex and data modeling is a tool to represent the various components and their relationship. The entity relationship model is a very popular modeling tool among many such tools available today. The ER model provides an excellent communication tool, a simple graphical representation of data. ER model uses ER diagram for graphical representation of the database components. An entity is represented by a rectangle. The name of the entity set is written within the rectangle. Some tools prefer to use uppercase letters only for entities. The name of the entity set is a singular noun. Next one, the line represents a relationship between two entities. The name of the relationship is an active verb in lowercase letters. The type of relationship 1 is to 1, 1 is to m and m is to n between entities are called connectivity or multiplicity. The decomposition from m is to n to 1 is to m involves a third entity known as a composite entity. In a database, there are entities that cannot exist by themselves. Such entities are known as a weak entity. Some of other elements considered in the database design are simple attribute. Attributes that cannot be subdivided, for example, last name, city or gender. Next one, composite attributes. Attributes that can be subdivided into atomic form. For example, a full name can be subdivided into last name, first name and middle initial. Next one, single valued attribute. Attributes with a single value. For example, employee ID or date of birth. Next one, multi-valued attribute. Attributes with multiple values. For example, degree codes or course registration. Next, normalization in DBMS. Normalization in DBMS is a technique using which you can organize the data in a database tables so that there is less repetition of data. A large set of data is structured into a bunch of smaller tables and the tables have a proper relationship between them. DBMS normalization is a systematic approach to decompose tables to eliminate data redundancy and undesirable characteristics like insertion anomaly in DBMS, update anomaly in DBMS, and delete anomaly in DBMS. It is a multi-step process that puts data into tabular form, removes duplicate data, and set up the relationship between tables. Why we need normalization in DBMS? Normalization is required for eliminating redundant data, therefore handling data integrity, because if data is repeated, it increases the chances of inconsistent data. Normalization helps in keeping data consistent by storing the data in one table and referencing it everywhere else. Storage optimization, although that is not an issue these days because database storage is cheap. Breaking down large tables into smaller tables with relationship so it makes the database structure more scalable and adaptable. Ensuring the data dependencies make sense, that is, data is logically stored. Types of DBMS normal forms. Normalization rules are divided into following normal forms. First normal form, second normal form, third normal form. First normal form. It should only have single valued attribute columns. Values stored in a column should be of the same domain. All the columns in a table should have unique names and the order in which the data is stored should not matter. Let's see an example. If we have the employee table in which we store employee information along with the employee skill set, the table will look like this: employee ID, employee name, employee mobile, employee skills. The above table has 4 columns. All the columns have different names. All the column hold values of the same type, like employee name has all the names, employee mobile has all the contact numbers, etc. The order in which we save data doesn't matter, but the employee skills column hold multiple comma separated values. While as per the first normal form, each column should have a single value only. Hence, the above table fails to pass the first normal form. So, how do you fix the above table? There are two ways to do this. Remove the employee skills column from the employee table and keep it in some other table. Or add multiple rows for employee and each row is linked with one skill. Create separate tables for employee and employee skills. So the employee table will look like this: employee ID, employee name and employee mobile. And the employee skill table look like employee ID and employee skill. Next one, add multiple rows for multiple skills. You can also simply add multiple rows to add multiple skills. This will lead to repetition of the data, but that can be handled as you further normalize your data using the second normal form and the third normal form. Look like employee ID, employee name, employee mobile and employee skill. Next one, second normal form. For a table to be in the second normal form, it should be in the first normal form and should not have partial dependency. Let's take an example to understand partial dependency and the second normal form. What is partial dependency? When a table has a primary key that is made up of two or more columns, then all the columns in the table should depend on the entire primary key and not on part of it. If any column depends on a part of the primary key, then we say we have partial dependency in the table. Let's take an example. If we have two tables, student and subject, to store student information and information related subject. Student table like student ID, student name, branch, and subject table look like subject ID and subject name. And we have another table score to store the marks scored by students in any subject like this: student id, subject id, marks and teacher name. Now in the above table the primary key is student id plus subject id, because both these information are required to select any row of data. But in the score table, we have column teacher name, which depends on the subject information or just the subject ID. So we should not keep that information in the score table. The column teacher name should be in the subject table, and then the entire system will be normalized as per the second normal form. Updated subject table look like subject ID, subject name and teacher name, and updated score table look like student ID, subject ID and marks. Next one, the third normal form. A table is said to be in the third normal form when it satisfies the first normal form and the second normal form, and it doesn't have the transitive dependency. What is transitive dependency? In a table, we have some column that act as the primary key and the other columns depends on this column. But what if a column that is not the primary key depends on another column that is also not a primary key or part of it? Then we have transitive dependency in our table. Let us take an example. We had the score table in the second normal form above. If we have to store some extra information in it, like exam type and total marks. To store the type of exam and the total marks in the exam, so that we can later calculate the percentage of the marks scored by each student. The score table will look like this: student ID, subject ID, marks, exam type and total marks. In the table above, the column exam type depends on both student ID and subject ID, because a student can be in CSE branch or the mechanical branch. And based on that, they may have the different exam types for different subject. The CSE students may have both practical and theory for compiler design, whereas the mechanical branch students may only have the theory exams for compiler design. But column total marks just depends on the exam type column, and the exam type column is not a part of the primary key, because the primary key is student ID plus subject ID. Hence, we have a transitive dependency here. How to transitive dependency? We can create a separate table for exam type and use it in the score table. New exam type table look like exam type ID, exam type, total marks and duration. We have created a new table exam type, and we have added more related information in it like duration, that is the duration of the exam in minutes. And now we have uses the exam type ID in the score table. A table that has transitive dependency is not in third normal form, but it needs to be decomposed further to achieve third normal form. However, a table in second normal form that does not contain any transitive dependency does not need any further decomposition, and it is automatically in third normal form. Other higher normal forms are Bayes code normal form, fourth normal form, fifth normal form, and domain key normal form. Thank you.